Hello, welcome to Tech Update 1A. I say 1A because this is not Tech Update 2. This is exactly the same code, bar a few minor changes, that was in the last Tech Update. But what this is doing is this is giving me a platform to explain to you where the V in my engine name comes from. So it's the Zealous Versatile engine. It was originally the Zealous Vulkan engine, it's now Versatile, because I've gone cross-platform and cross-graphics API. So I'm aiming to implement for DirectX, for various versions of DirectX, for Vulkan and for OpenGL. As you can also see, this is not Windows. This is Ubuntu Linux. I've gone with Ubuntu Linux on my laptop for a while. My daily driver in there is actually Arch, but I use Ubuntu on this laptop for ease of problems while I'm out and about, not having to recompile things or alter things and stuff like that. This is just dropped onto the low power machine and off it goes. Another thing you'll immediately recognise perhaps is the generator. This is the XVE generator. It's just a fancy wrapper for CMake. So this lets me pass certain commands and values to CMake. It also lets me run my code gen up front as part of my generate of the make files. So I run code gen from my definitions to give me source code that will build into my project. And if I'm working on something and need a new code generated type or something that's common across all my users, I just hit regenerate. So if we actually let that happen, you can see all my calls to CMake here. Hopefully we'll see CMake start to behave itself any second. There we go, and CMake should be done there. Build files have been written too, so we can now actually go to that location. I can feel the lag from recording, so this will probably really hammer my frame rate. Please forgive this while we actually build the code for the first time. So this is the IMGUI library, which is the first library I actually start to build. There's a few things from my base library here as well. Here comes the base geometry. So there's the IMGUI done. It's carrying on now building the rest of the base library that I use. And the base library contains things like simple API abstractions for utilities, file handling, compression, some noise functions. It has some basic types in it, has maths in it, but it also contains inclusions of other things. So it includes SDL cleanly for me, it includes SDB image for me cleanly, things like that. It's also got some platform things in there, so differences between Windows and Linux. It has some of the items that control the threading or the message system or the system bus in my engine. So systems are in the ECS sense of the term. They are a system that work on a subset of entities in my ECS, but the ECS itself is a separate entity. The system lives in the base, and that's very distinctly done because the API to my ECS library could change at any time. The API doesn't change, but the ECS library does. So I try and keep that interface the same, so it doesn't matter what the implementation is, the actual base system doesn't really care. And there are cases where I find something I want to add into the base implementation and use, so they all exist. XML is the other big thing that I have in the base library, so all the XML support stuff, because my code gen is generating to read and write structures to and from XML. XML is also how I will be transmitting certain values over the Ethernet, the networking when it's enabled. Right now it's not enabled. Networking is a whole separate kettle of fish. So there's the base library finished building. This is the source code for XML. So these are my generated types basically. So these are the real generated types. So I've got things for the ambient light, directional lights, debug components, debug cube, sorry. I've got compound components, the ground settings, fog settings. I've got a camera, I've got a line. I've got some map configuration stuff. I've got materials for drawing. These are all generator code. So this code was not touched by a human. So there's objects, there's points, there's the player's ship position, a point light. Some projection settings base. So projection settings base is the XML base, but the actual implementation stuff is higher up, and I can re-implement some bits and bobs that I want to however or wherever or in whatever style I fancy. So a renderable is the minimum set of, here's a piece of geo, here's the texture, here's the shader, go and draw that thing, materials and stuff. So skies, screens, the actual vertex types, the vertices that go into the mesh data. So I've got a 2D vertex for UI stuff, I've got 3D vertex for obviously 3D shapes, I've got triangle, as you can see, which is 3 points. Foo, I think, was a test. Classic foo.cpp is just a test. This is really slow while I'm running OBS. So this laptop it's just an Lenovo E480 ThinkPad, and it's showing its age. It's got a literally broken RAM slot, so I can only put one DIMM in there. There's only 16 gigs of RAM in the one slot that still works. It's a 4-core 8-thread machine, 8th gen Core i5. It's really done its work, but it's getting to end of life as we reach over halfway through 2024, and I'll be blog posting once again on what on earth to do in regards to buying a laptop. This was a very successful purchase. We actually have 2 of these in the house, 2 of these E480s. But this one is showing its age for my users. So here's the ECS library. You've just seen the input library finish. So the XML library, then the input library, and now the actual ECS. So you can see my entities, the type list, the component storage. I have a tracker for entity IDs. There we go. And now it's just building GLAD, because I use that as my loader for GL and Vulkan. And this is a bunch of the renderer stuff. So the renderer is separate from the rest of the engine as well. The only thing I'm currently working on in the renderer is getting the transform 3D stuff a bit more clean, because in the actual ECS I want to support a transform hierarchy a bit better between the various entities that are in the ECS. I want them to be able to render out and cumulatively have a relationship. So you place a good example is a turret on a tank. I want to place the tank on the ground, it be in a position, but then the turret is on the tank body, and they rotate completely separately. I currently support that multi-meshing, so I can have an object that is a tank with 2 meshes. Those 2 meshes have completely separate transform information, but the actual calculation of it is quite heavy, and it cache misses. That's one of the key things I've got a problem with. I could create them at completely different positions in the component storage. It's not intentional, and 9 times out of 10 they are right next to each other because they're being created at the same time. But there's no guarantee, because any entity on any thread can be being created. It can reserve a slot for a component it's about to put values into. They're called my overrides. They're loaded from disk. Depending on how quick your overrides come in depends on how quickly you'll get a slot, and therefore, or you could just be mixing it up. You could be fantailing between it. And when I've noticed that I can save out an entire scene and then load that entire scene up in one go, one of my performance bottlenecks or problems is I cache miss later on, because the body of an entity might be far away from it. And this wasn't the main problem I saw. So the main problem I saw was actually I had a test with an aircraft. So I had a very simple aircraft with wings, a tail, a few bits and bobs. It had 4 missiles, 1 on the tip of each wing and 1 on the centre of each wing. It had a bomb modelled down the centre of the wing on the centre fuselage. So I had 6 interrelated models. I then wanted to actually animate the wheels coming down as undercarriage separately. So then I had another 2 models, one for the left wheel, one for the right wheel, and then another one for the nose wheel. So I've got this jet, I've got all these sub-meshes, they all want to inherit from each other, and they were all fine in test. They were all absolutely fine. I saw no performance degradation. Later on, I let it spin wild. It's just finishing linking now, it would be good. Let it spin wild, and I immediately noticed it was cache missing all over the place. You as the player could not notice, but I noticed as the engineer, and that was important to me. So now we go back to the root directory, we go to run, and this is really slow while I'm recording with OBS. There we go. It is working. It's very smooth with OBS not running, so this is OBS killing the performance of the machine, but it's exactly the same demo that you've seen before. If I go to select a sky, I can select a sky. Now that's an interesting difference. If you watch, there's actually a frame of blank black there. That doesn't happen on the other machines, or it's happening so quickly you don't notice it, but on this machine that's fairly slow, I do see it, and that's why I'm keeping this machine as slow as I can. This machine is basically min-spec. It's an Intel integrated graphics 620, I believe. The machine has 16 gigabytes of RAM total, and it's sharing that RAM with as graphics memory. It has no real dedicated graphics memory. So this is my min-spec machine. I suppose number of processors I require is probably dual core or one core, one thread. So 2 logical cores total is probably the minimum. There isn't a major issue with anything else there. There's certainly not enough content yet for me to make that call. I'm going to say perhaps dual core, quad core minimum, and graphics is going to be this, the Intel 620. So this game and this engine should run on nearly any modern platform or machine you've got, and fairly old pieces of hardware to 2018 upwards. You can just see the floppiness of the waves on the distant horizon there, and you can see them moving around here, moving up and down. So that's Tech Update 1A. The XVE runs on Linux. I actually 90% of the time develop on Linux, just not this machine. As you can see, I keep trying to keep things clean and tidy and correct. I'm actually going to clear up some of this mess here. There was one interesting problem I ran into in the Brambling application, and that was here. So if we're on this machine, I could not support multi-sampling in any way. I just had to turn it off. It's not an MSVC thing here, as I've got it highlighted in the code. This was actually a Linux thing, this graphics thing. So I have the situation that I need to work on this implementation's number of multi-sampling. So that's what I'm going to work on next, effectively unifying all of this. And this needs, of course, also repeating for Vulkan. I've got the Vulkan implementation elsewhere. It needs to come in here and bifurcate depending on the value up here. This is just a quick and dirty GL integration. Obviously I'm using SDL GL, so I'll be using SDL Vulkan for the, well, I already do, I'll use it for the context for Vulkan there. So I hope that's useful, interesting, somewhat informative. I do hope to see you all soon. If you like this video, do like it, because it lets me know that you liked and want to see more of this. And if you want to definitely come back, subscribe please. And I'm hoping that the button did that magical mystery thing in the bottom on YouTube. When the first time you say subscribe, it highlights the icon and button for you. So hit that like button, hit that subscribe button. I'll see you all soon in XVE land. And there's OBS eating all my CPU for you. I love you all soon. Bye bye.